Welcome to the video. So today we are going to solve another Math Olympiad problem. So the problem is, if a sub n is the remainder when 7 to the power is divided by 11, right? Then we have to find a1 plus a2 plus a3 all the way up to a2024. That means the last term is going to be the remainder when 7 to the power of 2024 is divided by 11. Now, this looks like a complex problem if we go about solving each digit. It's impossible. So, what exactly this question is trying to ask is a concept called modulus operation. So, how it works is, let's say if A is any number which is divided by B, we call it A mod B. When we have to find a remainder of A when it is remainder when A is divided by B. So it is called A mod B. So let's say in our problem, when 7 is divided by 11, it is like we call it 7 mod 11, and actually it is 0 remainder 7, right? So 7 is not divided by 11, so the quotient is 0 and then the remainder is 7. So here a1 is 7. Now let's go one step further for the second value of n. So this is n is equal to 1. Now for n is equal to 2, 7 square divided by 11 is 49 mod 11. So 11 goes 4 times 44. So this is 4, and then remainder will come out to be 5, right? So what is a remainder term? Is 5. So a2 will become 5, correct? Now let's go into the third term, which is 7 cube divided by 11. So if we multiply this by 7, 7 into 9, 63, 6, 7 into 4, 28, and then 343 mod 11, which is 31 R2. So A3 will become 2. Now, we cannot go on and solve each of those terms, but what we have to find is, how do we get first, as a step 1, how do we get the remainder for each of those terms? Is there a pattern that will emerge, right? Anything if you divide by 11, either a number is divisible by 11 or then the remainder will be 0. If it is not divisible by 11, then the remainder is going to be between 1 and 10, right? So that is one thing that we have to find a pattern somehow. The second thing is, okay, let me write it down. So first is find a pattern from n is equal to 1 to n is equal to 2024. Then the second is, we cannot, let's say even if we have to find a pattern, how does this modulus operation work? Is there an easy way to do that instead of multiplying this by 7 and 7 and 7? So essentially we have to find a pattern from n is equal to 1 to n is equal to 2024, which is repeating, so that we can easily calculate all the individual values of a sub n. Now, let's say if 7, 5, 2, there is no pattern that is emerging as of now. But let's say if we have to know what are the next few more terms, how do we go about it? If we keep on multiplying 7 and 7, eventually this number is going to grow very large. So we have to find a way to reduce that multiplication. So if we look at this, is there a way that we can find the next remainder based on the previous remainder. So if we look at this n is equal to 2, so what we have is we have a 49 divided by 11 is 4 times 11 plus 5 by 11, which is what I have written here. So that is the 4 is the quotient and then 5 is the remainder. Now let's say if we multiply 49 by 7, which is the 7 to the power of 3, what we are essentially doing is we are doing 4 times 11 plus 5 the whole multiplied by 7, and this one we are dividing by 11. So this will come out to be 4 into 11 into 7 plus 5 into 7 divided by 11. So this term here, 4 into 11 into 7 by 11, this term we know for sure this is going to into the quotient. The next we have is 35 by 11, which is 7 into 5. Now we see that if we have to divide 35 by 11, it will go as 3 for 33 and then 2 will be the remainder. So this remainder is the same as what we got here. So essentially the remainder of the previous term, if we just multiply 7 to that, we will be able to find the remainder of the resulting multiple or resulting answer if we divide that by 11, right? So essentially if we multiply 5 by 7, that will become 35. Then we divide it by 11, so that becomes 33 R2. So the 2 is the same as A3 here. So this is how. Let's write down a few more terms. So let's say n is equal to 4 will become, which is 7 per 4 divided by 11, or 7 to the 4 mod 11, which is congruent to 2 multiplied by 7 mod 11. So this is congruent to 14 mod 11. That means our A4 is going to be 3, because 11 will divide 14 in one time and then the 3 will be the remainder. So for n is equal to 5, similarly, we can do 3 multiplied by 7 mod 11. So that will give us 21, 21 mod 11. So that will be 10. So A5 is equal to 10. N is equal to 7 is 4 times 7. So what we are seeing is 7, 5, 2, 3, 10, 4. There is no repeating pattern. So it seems like once it finishes the 10 digits, which is from 1 to 10 as a remainder, then it will have to go back to 7. So in this way, we go from 7, 5, 2, 3, 10, 4, 6, 9, 8, 1, 7. So after 7, it will again be back to 5, 2, 3. So it is going to repeat this pattern again and again. So it will go from A1 is equal to 7 to A10 is equal to 1. And then every 10 times it will repeat. Okay. So now, so what we have is every 10 remainders which are A's, so A1 plus A2 plus A10 is a sum of 1 plus 2 plus 3 plus 4 plus all the way up to 10. Here we can use the formula of, so this will become 10 into 11 by 2, which will become 55, because it will cut here in 5, and 5 times 11 is 55. Okay, now 2024 will have these repetitions. If we divide this by 10, we will have 202 are 4. So this addition will happen 202 times, and then there will be 4 more terms. So what we need to do is we need to multiply 55 by 202 to get A1 plus A2 plus to A2024. We need to multiply 202 times 55 and add 4 more add first 4 more remainder terms. So 202 times 55 is 5 into 2 is 10, 0, 1, then 0, 1, 0, 1. So this will become 0, 1, 1, 1, 1. And then we have to add the first 4 terms. 7 plus 5 is 12, plus 2 is 14, plus 3 is 17. So we have to add 17 to this. So this will get us 7, 2, 1, 1, 1. So sum A1 plus A2 plus A2024 will be 11127, and that's our answer. Hope you like this video.